So from here, if we can construct a prefix code which the code word length lies between this, average code word length lies between hs plus 1. That is, we first theorem was this is first theorem, that average code word length is greater than or equal to hs. But if you have to put a prefix, this has to be like this, that is, average code word length should be less than or at least equal to this. This has to be less than this, because you'll at least add one bit as prefix. So this is the meaning of this, that average code word length is less than or equal to hs plus 1, and while it is greater than this condition is very important. And what in case of extended code, we saw that for extended code this was equal to nhs. We have seen this, so we can write like this: nhs less than equal to extended code is, see, the code word length is nhs plus 1. Or what you can do, you can write like this: hs less than equal to this by n, this is hs plus 1 by n. So this expression is also very important. And one thing to see from this, if you want to see what if n is very large, what will be the average code word length. This is average code word length in case of extended code. So if n tending to infinity, we can write it like this: limit n tending to infinity hs plus 1 by n. So what if this is infinity, this is 0, so this is hs. So if n is very large, it is almost equal to the entropy of the source. Okay, now from here we saw what is prefix coding. Now we'll see one of the most important type of coding, which is called Huffman coding. It is an algorithm which is very important. Let's understand what is Huffman coding.